So we are building the biggest, most powerful telescopes in human history. It's an incredible time for astronomy, which is why you might be wondering why a new scientific paper is arguing we need to build another one. You've probably seen some of the headlines, maybe about finding Planet X or even alien probes. But the actual argument in the paper is a lot more practical, and it all starts with a huge blind spot in how we see the universe. So let's break down what this study actually says. Right now, we are entering this amazing new era of giant telescopes. I mean, look at facilities like the Extremely Large Telescope, the ELT. It's under construction, and with a mirror nearly 40 meters wide, it's going to completely revolutionize what we can see out there. But, and this is a big but, the story isn't as simple as just building one giant eye to look at the sky. You see, the whole problem that this paper focuses on really just comes down to geography. These new super telescopes, they're being built in the Southern Hemisphere. And that's fantastic. It gives us this unbelievably deep and powerful view of the southern sky. But it leaves the entire northern sky with a massive blind spot, comparatively speaking. And that leads us right to the core question of this whole discussion, the one this paper really sets out to answer. If we're already pouring billions of dollars into the biggest telescope ever built, why on earth would a group of scientists argue that we need another one, about the same size but in the northern hemisphere? Okay, so to really understand their argument, we need to walk through it step by step. We're going to start with why this blind spot is becoming a really urgent problem. Then we'll dive into the 4 key scientific cases they make. We'll also spend some time on what they explicitly say this telescope won't do, which is super important, before we look at the picture. So what's the rush? Why now? Well, the urgency comes from this, just unprecedented flood of data that's about to hit us. We've got new sky surveys, like the Rubin Observatory, that are about to switch on. They're going to discover millions of new asteroids, comets, and all sorts of other small objects. At the same time, missions like NEO-Surveyor will find thousands of new asteroids flying near Earth. But here's the catch. Finding them is just the first step. To actually learn anything about them, like what they're made of or where they're headed, you need to quickly point a really powerful telescope at them for a closer look. And if one of these things pops up in the northern sky, well, our best new tools just won't be able to see it. And this brings us to the real heart of the paper. The authors build their entire case around 4 specific scientific areas, where having full sky coverage isn't just a nice-to-have, it's an absolute necessity. First up, interstellar objects. Okay, these are comets or asteroids from entirely different star systems, like the famous Oumuamua and Borisov. They're incredibly rare, they move super fast, and they can show up literally anywhere in the sky without warning. To study them properly, we have to catch them early, before the sun's heat basically cooks them and changes their surface forever. So if one appears from the north, we need a powerful northern telescope ready to swing into action immediately. And this isn't just a theoretical problem. This slide shows a perfect real-world example. The interstellar object, known as 3I/Atlas, will first show up high in the northern sky. It'll be completely invisible to the ELT down south. Without a northern counterpart, we would miss the most critical data about its original, pristine composition. We'd only get to see it months later, after it's been fundamentally changed by our sun. The original story is lost. Okay, the second case is all about that search for a potential 9th planet out in the depths of our solar system. To find it, or even just the clues it leaves behind, we need to spot these incredibly faint, slow-moving objects. And the paper argues that the northern sky is actually a better place to do this because it gives us a clearer background with less, let's call it cosmic light pollution from the crowded center of our own Milky Way galaxy. Third is something really practical: support for space missions. You probably remember when NASA's DART spacecraft smashed into an asteroid. Well, ground-based telescopes were absolutely critical to understanding what happened. But here's the thing. Whether a telescope can actually see an event like that depends entirely on where it is on Earth and where the target is in the sky. To guarantee we can support any mission going to any target, we have to have powerful observatories in both hemispheres. It's that simple. And the final case. This is the big one: planetary defense. A potentially hazardous asteroid could approach Earth from any direction. It doesn't care about our hemispheres. If a threat appears from the north, we would need a powerful northern telescope to quickly figure out its exact path, assess the real risk, and even determine what it's made of. The paper argues this isn't just for science. It's an indispensable piece of a global safety net. So those are the 4 main arguments for why we need this telescope. But just as important is what the paper explicitly says this telescope won't do.
This part is absolutely crucial for cutting through some of the hype you might have seen. The authors are incredibly careful here. They do not say this telescope will guarantee that we find Planet X. They do not claim it will find alien technology on interstellar visitors. They are not saying the ELT is a mistake or that it will be obsolete. And they definitely don't present this telescope as some magic bullet that solves planetary defense all on its own.
So if the argument isn't about those flashy headlines, what is it about? It's really about something much more fundamental. It's about building a complete toolkit so we have the right instrument to see any object anywhere in the sky at any time.
And this gets us to the key idea in the paper. This is not about redundancy. It's not about building a spare. It's about necessity. The authors see this project as complementary to the ELT, not as a competitor.
And you don't even have to take my word for it. They say it plain as day, right in the paper itself. A northern 30-meter telescope is therefore not redundant, but rather highly complementary and necessary. I mean, that one sentence really sums up their entire position. A good way to think about it is like this. The ELT in the south gives us incredible deep vision in one half of the sky. A northern counterpart would complete that vision. It's the two halves of a whole. It would give us the flexibility to respond to those time-sensitive events, like a brand new asteroid or an interstellar visitor, no matter where in the sky they happen to show up. Okay, so let's circle all the way back to our original question. Given what's actually written in the paper itself, what can we responsibly say about this whole proposal?
When you boil it all down, the argument follows a pretty simple logical chain. First, a flood of new discoveries is coming. Second, our best new tool, the ELT, can only see half the sky. Third, therefore, to take full advantage of these discoveries for both science and safety, we need a complementary tool in the other half. It's an argument about maximizing our return on investment for this entire next generation of astronomy.
So when you strip away all the hype, what this paper is actually saying is something very specific and very pragmatic. It's saying that to get the most out of all our other massive investments in astronomy, the sky surveys, the space missions, everything, our most powerful eyes need to be able to see everywhere all the time. And that really leaves us with one final, simple question that gets right to the heart of the author's argument. As we stand on the brink of discoveries that could literally rewrite our understanding of the cosmos, is seeing only half the picture really good enough?